All right. So, good evening, everyone. Thank you for joining us tonight. And today's event is organized by Women in Robotics Boston Group. I am Dharini Dutya, co-organizer of the group, along with Sanjuksha Nirgade. And we'd like to thank our Zoom sponsors, Vecna Robotics. Okay, let's settle down, and the participants can type in your questions in the Zoom Q&A icon, not in the chat, but in the Q&A section. And our panelists can try to answer as many as they can if time permits. And my friend Sanjuksha is going to be the moderator this time for you guys. Over to you, Sanjuksha.
Thank you, Dharini, for the introduction. So today we are here with another amazing event with some of the inspiring personalities. So about Bioinspired Robotics, to me, seems like one of the smartest things to do in robotics. Like nature is the best engineer, and like Bioinspired Robotics takes inspiration from the naturally engineered processes. So be it how the ants go into the whole formation process or how the fish swims the seas. On that note, I would like to really thank you, our speakers, to join us today, and also introduce a short introduction for both of our speakers. So we have Dr. Julie Adams here, and Professor Associate Director of Collaborative Robotics and Intelligent Systems Institute, Oregon State University. She has worked in the area for over 30 years. And she founded the Human Machine Teaming Laboratory at Vanderbilt University. Her research efforts have been featured in international news outlets, including National Geographic, Scientific American Podcast, Der Spiegel, and BBC Online. She has contributed to the field in Honeywell and Eastman Kodak Company. She also spoke at the TEDx Nashville, received the NSF Career Award, and was selected for the DARPA Computer Science Study Panel. Thank you so much for spending your precious time with us, Dr. Adams. We are absolutely thrilled to have you here, and you're a true inspiration to all of our members.
Thank you.
So
I didn't know if you were going on with the next introduction.
Yeah, I'll just introduce Ms. Thompson, and then we'll get back. So another speaker we have today is Ms. Thompson, the CEO of Aquaai, a marine robotics company from Norway. Aquaai has been awarded the Top Aquaculture Innovation Award 2019, Fish 2.0 Global Forum and Innovation Norway Grant, as well as given a Seal of Excellence by the European Union. Ms. Thompson's journey as an entrepreneur includes setting up new businesses in Hungary, Israel, and the United States, and most recently Norway. Ms. Thompson is also a TEDx speaker and an ocean advocate, passionate about providing her children a healthier planet. So using robotics technology for saving the planet is one of the most inspiring things we are going to know about today, and through Ms. Thompson, of course. And we are so glad you could make it after such a odd time difference. I know it's 11 p.m. at your place, and we are so thankful that you're here today with us.
Thanks for having me. Actually, we are a Silicon Valley founded company. So we've recently opened up a subsidiary here in Norway. So I tend to work California hours anyway, because, a lot of our investors and whatnot are in California, which is where I'm originally from.
Oh, that's my bad. I thought that the company was set up in Norway.
We opened a subsidiary about a year ago here because most of our customers are in Norway, and it just, when you're a startup, you go to where your customers are, and so it made sense for us to open up a sub here.
That sounds great. We're still really thankful for you to work with us with this time difference, though.
No worries. Thanks for having me.
So I will not take more time and start with knowing a little bit about both of you. So we can start with Dr. Adams.
Mm-hmm. As you mentioned, I've been working in robotics now for 30 years. And over that time, a lot has changed. The first quote unquote robot that I worked on, You know, we basically put a desktop computer on it with a laser, sorry, not with a laser rangefinder. We didn't have those, with an overhead projector to serve as our laser rangefinder. So, you know, we've come a long way to the small $100 laser rangefinders that we today can put on small unmanned aerial vehicles. So, you know, there's been great leaps and bounds over that 30 years, but we still have a lot of great leaps and bounds that we need to do. And so that's one of the things I think I find most exciting about my job. And one of the reasons that I'm always driven to work as much as I do. Everyone always tells me I work too much, and I think that's probably a pattern for women in our field and in engineering. You know, and so it's just the excitement of the field. You know, and so when you think about biologically inspired robots, there's a lot of different things that you can mean by that, right? So, for example, Jonathan Hurst, who's one of our faculty members, has worked on Cassie, the walking robot, and it's based on how ostriches walk, right? So it's purely biologically inspired. It's a very different type of biological inspiration than my work is. My work is much more focused on schools of fish, colonies of honeybees or ants, and how do we take those basic capabilities and put them into a small, inexpensive robot and have a collection or a collective of those robots do things that look intelligent and interesting. So there's I guess a broad spectrum there of biologically inspired and what that potentially means. So.
Yeah, I mean, like, I've heard about mostly like the whole collective biologically inspired robots, as you said, like honeybees and ants.
Mm-hmm.
So really interesting. So I have like a related question on that. So what is like the most upcoming work you're excited about?
Lots of things, all the hard problems, right? I mean, that's the thing that's great about robotics, right? And engineering is that once you solve one problem, or maybe get close to solving it, because I don't know that we've ever really solved some of the fundamental problems, even with single robots, but you want to make it harder and move to the next step, right? So when you're talking about hundreds of robots, you know, the practicalities of deploying those kinds of systems really become part of the forefront. And especially in academia, we don't necessarily pay attention to those issues. So what is the cost of an individual robot? And if you're going to have 500 of them, how many, you know, what can you actually afford? She's laughing, right? And what can they actually do when they go out in the real world? So, you know, you said, what is the most advanced thing that we'd like to do or be excited about? Well, you know what? We have a field exercise coming up in about a month, and we're going to attempt to deploy 150 vehicles that are a mix of aerial and ground, fixed wing and multi-rotor. And even within the multi-rotor, there'll be different types of multi-rotor vehicles. And we're doing that in an urban environment. And that is exceptionally challenging for all kinds of reasons that wouldn't be the fundamental things that you might think about. So it's not necessarily the AI, it's not necessarily how the sensors get integrated, but it's everything involved. And how do you actually get the entire system working, right? That whole ecosystem, if you would, working. We tend to think that Wi-Fi is going to work everywhere. No. We tend to think that cellular is going to work everywhere. No. We tend to think that satellite is going to work everywhere. No. You know, I won't go into the underwater world. I'll leave that. But you know, there's other issues there. You know, so there's just so many things that we take for granted that when you go out and try to deploy these systems that really make it challenging. And addressing all those problems is really kind of the things that really have to become advanced in order for us to get these systems out into the real world at the scale that I want to get them at. And the types of domains, let me just give you a little bit of context. The types of domains that I focus on are disaster response. So I live in Oregon. Wildland fires are a huge issue. As well, you know, military domains. I'll leave the ocean, but you know, there's lots of applications for swarms in ocean-based domains, environmental monitoring, things of that nature. So there's a lot of different applications for which we could apply these systems. The question is it better to have what I call a multi-robot system that might be 10 robots that are more advanced, more expensive, maybe cost the same as that 250 entity collective, and they have more, you know, that multi-robot system has more intelligence, maybe more advanced sensors, so it's more capable? Or is it better to have maybe some resiliency from the less capable individuals that can do things as a collective, and really getting things to that level where collectives really are functional and capable of doing things in the real world?
Sorry. Thank you so much, Dr. Adams. Let's now move towards the ocean. So, Ms. Thompson, over to you.
Okay, so yes, affordability is a major issue. I think because of the hours that go in from R&D perspective and also manufacturing, the only entities that could actually afford with their deep pockets robots beforehand, at least in the ocean space especially, were those coming out of oil and gas or military. And commercial industries, scientific research, they kind of were left behind because they didn't have the deep pockets. So I think affordability, at least in the ocean right now in robotics, is key. And also I guess we could talk about autonomous underwater vehicles, autonomous surface vehicles. So I actually came about this not because I am an engineer by all means, but because I met an individual who is a roboticist for 30 years, and I met him in Tel Aviv, and he had already been making at least a dozen 2-meter tall humanoid robots, and this was maybe 20 years ago, single-handedly to study human robotic interaction, I think long before it was even an acronym. And I met him, I was a journalist at the time, and I met him because I was doing a story on, you know, the Q, as in James Bond 007, the gadget guy Q of Israel, and that led me to him. And he had made a promise to his daughter who learned about the ocean crisis, who kind of grew up in his lab. And she came home from school one day and said, "Dad, enough with the land-based robots, please make a robot to save the seas." And so, as every good father would, he promised that he would, and started this, you know, big education about what systems were in the ocean to do, you know, currently, and what was needed to be in the ocean in order to live up to that promise. And because he has a background not only in robotics, but special effects and animatronics, as well as climate change, he understood one thing, is that Mother Nature got it right. So we were going to make a system that could withstand the superstorms that we're all seeing today as a direct result of climate change. And anyway, with the rough waters of the ocean, he knew that it needed to be able to look and swim like Mother Nature intended those species to swim right now in the ocean. And there came the robotic fish. So what I'm going to share with you actually, if you can see my screen at this moment, is the robot, one of the first robots. Are you seeing the robot swimming now in the waterways? So here are different versions that we looked at. As you can see, they each are very bio-inspired. At this point in time, they only had cameras. This one, we already start putting sensors on it. This is the ones that we're testing up near the Arctic Circle, in sustainable fish farms, in farms that supply Whole Foods and Michelin chefs with salmon that you can buy, as I said, at Whole Foods. So these are all different versions of the trajectory where we took from the first small little robot to the ones that we're doing now, up into this last final one that you'll see, which is our current version here. So this is our Namu. She's named after goddess of the sea. And she's, as I said, we've had about 8 of them swimming 24/7 in the Arctic Circle to gather an array of data from salinity, oxygen, pH, temperature. We have these newer versions that we were just putting in last month, have also sonar and GPS. But I think the entire point of Aquaai was to make affordable systems, ones that commercial industries could use. We do not work with military at all. We do and are capable of doing disaster response. And for us, it was really about offering that tool that would indeed enable, like sustainable fish farms, even, smart cities, coastal flooding.
We have something special.
Many different commercial entities, I should say, to enable us to be able to swim in those terrains. So it was really about having an affordable system and one that could be offered to multiple industries without having to go back to R&D so much. So a myriad of use cases.
Sounded really good, and especially the videos are really cool, by the way. Thank you for sharing so much with us. So we'll start with our questions now. We have a bunch of them lined up. So this one's for Dr. Adams. So we're going to go with the first domain specific. So I intend a question to each one of you. If you have, the other one can answer too. Please feel free that way. So starting with Dr. Adams, what is the most primitive and most advanced biologically inspired robotic platform? There are a lot of different aspects of animal behavior which can be mimicked into a robotic system. So how deeply should we look into the spectrum?
So I think it's, again, kind of like what I was saying before, the concept of biologically inspired is very broad, right? So I think I'll kind of try to focus the question just a little bit more in my response. So if I don't specifically answer what you wanted, please let me know. But, I think, you're asking kind of how far should we look into the biological inspiration, correct? Yeah. And so I think it depends on what you're doing. In the case of Liane's work and of Jonathan Hurst's work, where you're really trying to use that biological inspiration to create a very different form factor, a very different capability, then it's important to look at what are the strengths of the approach, but also the weaknesses. Where is that approach going to break down, and understand those so that you can bring in other aspects. So can you bring in knowledge of kinematics or knowledge of dynamics, or, we were having a conversation earlier today in one of my other meetings about the fact that a particular problem we're working on, and I apologize, I can't talk about it in this venue, but, a particular problem that we're working on has been solved for land-based systems. But when you take it into the ocean, there are things like current changes and turbidity changes. So turbidity is how cloudy is the water, right? How well can you see there? And so even though it looks like it's a solved problem terrestrially, it becomes a very complex problem when you put it in the ocean, for example. And so you need to look at, what are the limitations of that biological approach? And right now, one of the big questions that has been asked quite frequently, I've now been asked this question, I should say, by the same person twice since March, about, have we really reached the limitations of trying to apply biologically inspired swarms and collectives? So spatial swarms here are things like schools of fish and flocks of birds, and colonies are honeybees and ants and things, right? And so we started quite a bit of research 10 years ago, 12 years ago, on how do we take the biological inspiration to build those capabilities into systems, and how we reach the limits. And that's a big question right now. And in our work over the course of that time, there was a desire initially to try to really have the biological inspiration and really be able to have a very adaptive system. Because one of the biggest things when you go out into the real world is that it's very dynamic, it's very uncertain, it's not always structured. The water is very unstructured in many places, you know, in most of the places that I talk about working, it's very unstructured. So, you know, have you reached the limits? And I think that's a big issue, right? You have to learn when to stop and when to say, what's the other inspiration? And you know, one of the things I tell my students all the time, and I really take to heart, is I read a broad spectrum of things that are completely unrelated to what I do. Because a lot of the time I will see something perhaps in economics or perhaps in biology or in physics that seems completely unrelated to what I'm doing, but it can be that little token that really comes in and turns that cog and really changes your approach to the solution and gives you a new direction that really gets you over to the next level for the system.
So thank you so much. Like that really makes sense. Like you definitely need to know when to stop.
How do you want us to answer questions? So I see a question that is like, how much do you work with biologists? Do you want us to answer those like while we're talking, or do you want us to wait?
So we are keeping the questions from the audience to be answered at the end.
Okay.
So you don't have to worry about that now. At the end, we'll answer the most apported questions. So our viewers, our attendees would be apporting them. So whatever we have like on the list, so the most apported questions would be.
Okay, yeah, because that one seems pretty relevant to what we were just saying. That's why I was asking.
Yeah, you can go ahead if you want.
Yeah,
Sure.
yeah, feel free, yeah.
Okay, yeah, so we actually, it depends on what we're working on as far as the biologist. So we actually aren't working with biologists, we're working with a honeybee. I don't know what the actual term is for somebody who studies honeybees and works with honeybees, but I work directly with the director of the honeybee lab at Oregon State, and we've conducted studies with honeybee colonies to understand certain types of behaviors in order to take the information we gain through these quantitative evaluations in order to derive controllers that we'll put into our colony-based robots. So it really depends on the particular problem that we're working on and the particular funding that we have. But we do work with biologists, or we take the inspiration from them.
Very nice. So going to Ms. Thompson again, we're learning algorithms used in building the Aquaai robot unit, like where it learns from the fish. Like, can you please elaborate on that, how it works? Like, how does it learn from the fish?
How does oh, okay. So right now we use, we have about 3 cameras on board, and we use computer vision and AI to learn its environment so that it can swim alongside the fish. The goal is to get up close. So we believe in terms of data acquisition, proximity to the source is key. So especially in the case of, let's say, the sustainable salmon farms in the Arctic Circle, near the Arctic Circle that we're working, they have buoys, much the same as the sensors that we have on our robot. They would have typically on buoys around, you know, the cages, and it's, yes, it's, you know, the salinity, the oxygen, the pH, the temperature and whatnot. But how good is that if the sensors are on the cage and your fish are on the other side of 120 meter circumference cage? So by putting all these sensors and cameras on, we swim alongside, and we're able to then gather better data, which goes to our back end, and then is pushed forward on a customer web dashboard to the customer to see the analytics part. So we're using, at the moment, as I said, we're using the AI and the computer vision aspect mainly for navigation. And then as we go and grow, we'll be using more machine learning for the analytics.
Yeah, that is what we were thinking more like if you're using any particular learning algorithms for that. But yeah, that sounds great.
Yeah, and also, just to touch upon what Dr. Adams is talking about in terms of swarm, for us, it's really about having a few of the units, depending on the size of the location that needs to be monitored, whether it's inside or outside the cages, or in rivers, let's say, there's a lot of need to understand what's coming through our riverways that's actually getting out to the ocean. So if you're going to say the seas, you may as well start in the rivers. And we'll have multiple fish where they are indeed talking to each other and docking. Again, it was pointed out about the communication. How reliable is the communication, especially when you are working in oceans and below the surface. So you're having to use everything from Wi-Fi. We also go into the networks of the places that we are monitoring. We tap into their internal networks. So it's a variety of ways to transmit the information.
Thank you. So on the whole collective part of it, back to Dr. Adams. So how can collective robotics improve a solution approach? Like, what are the advantages that they have over multi-robot systems?
So one of the reasons to think about biologically inspired collectives is that we know from the literature and from various systems, various biological systems, that they're very resilient. And what I mean by that is they're very adaptive to things coming into their environment. They are able to lose a large number of their group and still be able to perform their task. There is some question, especially with things like salmon, about how global warming is impacting, for example, fish, and how that's impacting their behaviors and how they're adapting, and whether it's good or bad how they're adapting. But in general, one of the reasons really to look at these kinds of systems is because they bring, or should bring, a lot of capabilities and resilience that you wouldn't have otherwise. At the same time, they bring a lot of complications and difficulty. But yeah, I had one other thing I wanted to say before I went into the difficulties. What was it? It'll come back to me. There's too many thoughts going in my head because there were threads that I wanted to pull on other things. But the difficulties are that even in a biological system, typically in spatial swarms like fish, there will be a small number of the individual entities that have information that the rest of the membership does not. And so those individuals that have information are called leaders, and their behaviors are influencing and guiding the biological system, right?
Yeah.
And the rest of the entities really have no idea what they're doing. They're just kind of moving along, responding to things locally. So it's very distributed and it's very local communication, and oftentimes it's very indirect kinds of communication. And even within biological species, for example, in fish swarms, it's not uncommon to see fish swimming in the opposite direction of the entire swarm, and you don't notice it with the human eye. Because what you see is the overall sequence of things. So, this is one way, this kind of resilience to these things is important. However, the downside is that now you have to have distributed communications. You have to have distributed capabilities. You don't have rich communications like we typically think of with robots that are in home environments or warehouses. We were just talking about tapping into the networks available at the fisheries. And a lot of the places I go, there is no network to tap into. If you go to the Cascades Mountains, there's a lot of places where there's no cell coverage. So how do you get that communication? You can't go in and set up a communication system during a wildfire, right? So what are the alternative means of providing that so that you can then have the behaviors? One of the things that we're working on is indirect communication, which is very perception based. So it's not sensing lights or things like that, but actually sensing what the other entities in the system are doing and responding appropriately. So I talked about that leadership. How do we have a few members, just enough members that have that additional information about what the goal or objective is, and they have the capacity to influence the overall group to do that particular task? That's a very difficult thing to do. And so, you know, there's not fundamental decision making like we typically think about in a single robot where we have a lot of processing. It tends to be more abstract and more embedded into the environment and the environmental influence. So, you know, if you think back to the subsumption architecture developed by Rodney Brooks, you know, the idea there was to embed the world model into the world and use that to influence the behaviors on the robot. And it's very similar here. So how much can you use your environment, not only as a model, but also as an influence on the collective's behavior?
I had a follow-up question. Can you give an example of such influencers which can alter the behavior of the collective?
Do you mean an example of leadership?
No, you mentioned external influencers.
External influence.
Yeah,
Sorry,
yeah.
I wasn't clear which type of influencer you were talking about. So one of the videos I typically show is a video of a shark going after sardines against a coast. And when you look at that video, you can see that a very small portion of the overall swarm is kind of avoiding that shark, and the rest are reacting to something else completely. They're reacting to being too close to shore and trying not to get stuck in the sand, right? And then there's a whole nother section of the swarm that is doing just the regular thing. They have no idea that these other two sections of the swarm are dealing with these external environmental influences on their behavior. And so that's one good example in biological species. In real world environments, if you think about trying to respond to, say, so the other thing in the Pacific Northwest is we have a lot of earthquakes. And in Oregon, I just moved here 4 years ago, but you know, the big thing everybody said to me when I moved is, you got to prepare for the big one. We're going to have the big one and it's going to be a disaster. You know, and so when you think about having a space like a city, so Portland, you know, I'm thinking about like LA after the earthquake in 1994, I think it was. I don't remember when the bridges collapsed or the overpasses collapsed. You know, you have an environment that's changed. So if you just use something like Google Map to be how your robots are going to move throughout the environment, and then this earthquake happens, it's completely changed the environment. So how do your robots deal with that? How do they know where they can go and where they can't go? You know, so that's another example of that. And even in the situation or scenario where there isn't something destructive like that, you know, there are just dead zones in certain areas. There's urban canyons, right? So your system adapt when they get into that situation. The system has to be able to be autonomous, even if it doesn't know exactly where it's positioned and know where its goal is and how it's proceeding to that goal. That's not specific to collectives or swarms, it's specific to a robot, right? Even a single robot.
Yeah, so based on the same thing, like the whole uncertainty of the environment. So over to you, Ms. Thompson, like how do you deal with the uncertainty of underwater environment? Like, did you face any constraints on the design or safety incidents because of this?
I think for our concentration was not to build something that to be used for research. It was always to build something that would be a product, which meant that it needed to be, again, I'll reiterate, affordable. So obviously, by using a bio-inspired design, my partner was able to create something that had very, very few links and almost zero screws. So that does a couple of things in the design factor. One, as a product, you have very minimal maintenance because with fewer links, there's fewer breakage. Even when you're, impacted by waves, as I said, we're swimming sometimes in 4 or 5 knots or waves that are in gale winds. We were last month, our robot was swimming through. Also, we're able to, that also keeps the cost down for manufacturing. So again, we're not passing that off to the end user because it is a product. We're also able to use the design for efficiency. So for power efficiency, by using fin propulsion, we're able to kind of glide along and even pick up on the inertia of whether it's the Gulf Stream or in the case of the fish farms, along with the fish. So we, in that we've been highly, highly successful. Our patents are in mechanics and design. And we have, as I said, really focused first and foremost on the mechanics and design of the units, and are adding to the software capabilities, constantly, as one should, as it evolves. But for us, it was really about how can you make a system that doesn't cost dozens of thousands of dollars, but a lot less, and be able to use that and withstand those rough terrains. We were fortunate here, talking about how we are swimming with the fish, or whether or not the fish, at least in the salmon, and we've swam with koi, we've swam with duck, whatnot. They all tend to adopt our systems. We're almost kind of the mummy, the mothership, maybe because we're larger. So in studying cohabitation between wild and farm salmon anyway, and this is a research project we will be doing with NOFEMA, which is the top aquaculture research institute here in Norway, is studying kind of how the moods change, because fish do have moods. So we're looking at the behaviors, we're looking at the different moods, and we're able to keep developing our technology with the latest sensors that come out that are smaller, and hardware that comes out. We 3D print everything and SLS print and everything in-house, and our sensors and cameras are off the shelf. And we're supported by entities like Innovation Norway with a grant, so that we're able always to to go forward, but also to work with different research institutes while we develop a product that is to be used daily. Our robots swim 24/7 in the water. It's not that we put them in and take them out, so they're 24/7 in the water. The last one we had was swimming for about 8 months. Yeah, so for us, it's really about durability, efficiency, and affordability.
What about biofouling? Do you have to, did you find that the simplistic design helped you deal with biofouling?
Yeah, actually, yeah. We were really, really surprised on that front. And it could also be because we are up in the cold and there's always the currents, but we didn't have after even 8 months, we pulled them out and there was only just a little bit of green. We were astonished.
That's awesome.
Yeah, it is definitely. So moving on to the next question for Dr. Adams. What parameters can be manipulated by human controlling a team of robots? Like, how is it different from controlling a single unit than a team?
So I could talk for years on this because this is basically what I have done for 30 years.
Oh, okay.
I did the first human robot, quote unquote, human robot interaction user evaluation on a multi-robot system back in the early 90s. So we definitely did not have that term then, and I could not get published because most people didn't want to hear about a human having to interact with a system. They wanted it to be fully autonomous. So I could literally talk for days on end about that topic. So I will not do that. But you know, I talked about being able to influence the collective and the way that the leaders influence a biological group. And when you're talking about a very large collective, generally that's what you want to be able to do. If you try to have a human directly interact and control even 10 robots, it is not going to work. You're very quickly going to exceed the human factors capabilities of that individual. So their ability to attend to multiple things. I know that today we live in this world where we're constantly multitasking. You know, I had one of my students say to me today, I have no idea how you get work across all the different things you do in a day. And so even though we constantly multitask, that does not necessarily help us with trying to supervise multiple vehicles, right? And we think about practical applications like Amazon wanting to use drones to do deliveries, right? How do you have one person supervise, say, 10 different drones going out into the environment to deliver packages? Well, you know, that is what I would call a loosely coupled task, meaning that the individual UAS, unmanned aerial systems, are not having to cooperate, right? They're going, I mean, they have to cooperate in that they need to deconflict their airspace. They need to not run into each other, right? But they're going to separate locations to deliver those packages. That's a very different scenario than what I would call a closely coupled task, in which you want the group to maneuver through an environment and look for potential victims after a disaster, right? You want to use a systematic, structured means of transitioning or navigating through that environment while also perceiving the environment, trying to identify potential places where victims may be trapped or potentially buried, for example. And so therefore that becomes much more closely coupled, and that's much harder to influence. And that's where those leaders that I was talking about could come into play. Because you aren't going to be able to interact with each one of those individual robots simultaneously. So how do you bring that up to what we call more of a teaming relationship? And that's especially where you might want some decision support, some system that is running both locally and distills down that raw perception information into what actually needs to be communicated to the human, and understanding what's most relevant to the human, as opposed to sending 15, 20, 30 video streams, because we can't pay attention to that, right? So that's a whole Pandora's box that you just opened. And so, you know, there's lots of different approaches to do that. There's lots of different perspectives on how to do that. You know, and I think it really somewhat depends on the types of tasks that are being done, the capabilities of the system, the capabilities of the operators. Are they trained, right? So one of the things that is not part of my swarms research, but is part of my other research, in which we look at how humans and robots can physically be in the same environment working in these scenarios. You know, how can you use things like physiological sensors or speech rate to identify what's happening with the human so that the robot can adapt and interact with the human appropriately, or redistribute tasks because the human is busy doing something, so the robot needs to take on a task. So being like a true teammate as it would be with a human team. And so there's so many different parameters that can be manipulated in so many different ways. That's just a really hard question to answer, and it's very domain and task specific.
Yeah,
We can have a separate event on that topic if you like.
yeah, definitely. So like a follow-up thing on that. So emergent behaviors and leadership model that you mentioned are like unpredictable, and predictable behavior is more important in industrial applications. So how can we deal with that? Like, when will we see collectives as a solution in automation? Like, how can we show?
So that is a very important point. And even in non-industrial situations, that level of predictability is really a confounding factor. You know, I don't care what level of robot you have, autonomy these days is still very unpredictable, unless you have it in a very well-defined environment. So if you have Amazon warehouse robots in the warehouse, That's a very well-defined environment, and that is an environment where the behavior is completely predictable. However, if you take an autonomous vehicle out into the world, or you take a delivery robot, so we currently have, starting a couple months ago, robots on campus that are delivering food to students in the dormitories. And you know, some of the students who work in robotics are like, I don't know what this robot's doing, because it's just sitting there and it's not following the laws of the road. And in Oregon, if there is a pedestrian waiting to cross the road at the crosswalk, cars have to stop. And, you know, the cars are stopping on campus waiting for the robot to cross in the crosswalk, and it's not crossing because it sees a car, so it's not crossing, and there's this, you know, this deadlock that happens. You know, so there are a lot of these types of issues that have to be addressed, you know, and so it becomes very difficult to get that predictability and that trust. You also don't want to over trust, which is another issue that often occurs, where people just assume, okay, it worked, it's been working well for the last 6 months, I can ignore it and go do something else, right? And in fact, it now encounters that one situation that it hasn't seen. It starts to take an emergent behavior that you're not anticipating, or maybe that you don't even recognize because it looks like something that's similar to what we've done or the robot has done, right? So we as humans are case-based reasoners, meaning that we adapt to new situations by figuring out what we've already done that is similar and adapting that. And so that can often mask what we see happening with the robots. So there's such a confluence of issues there that it's like, you know, a 10-day discussion.
Yeah. And I think it's like with robots, I mean, humans have to learn to interact as well. Like you gave that example, like, should I stop for the robot or should I let the robot go? Like, what should I be expecting from the robot? Should it be behaving like a pedestrian or like another car? So
Right.
I think that'll definitely take time for the society in general, I guess.
Mm-hmm.
So moving on to Ms. Thompson again. So your Aquaai is like, how beneficial is the whole leasing unit-based business model? Like, is it circumstantial decision or it would be like the same in future?
The decision to lease the platform and then offer the data on a subscription model was intentional, essentially. So we did not want to have a scenario whereby you sell a product, in this case, you know, the robot, and then, you know, there's issues with it. You have unhappy people, they own it, they bought it, it doesn't work. I mean, this is a completely new terrain that we're in. You know, again, autonomy, does it really work 100% of the time? No. Same with AI. I mean, what is really AI? So we didn't want that issue. And you're also looking at putting something that, again, you know, is affordable in the water 24/7 to do environmental monitoring and understand the characteristics and, you know, obviously the video and whatnot. But what if something goes wrong? At least if we own it and if we're leasing it, you know, we also made them incredibly modular, like Lego, so they come apart really easily. I can take it on the plane with me, it's not a problem. and we're able to swap out parts if there is a need to do that. So it was really, there was a lot of thought that went into it about, no, we're not selling the robots as a product. We're leasing also upgrades. You know, technology is going so fast that you're always upgrading. So the mechanics we had in our unit we put in the water a couple weeks ago were much different in the sense of what we had 2 years ago on the robots. So we're always upgrading. The sensors are always upgrading. So it was very intentional. And also, finally, I just wanted to say, it's very important for us to also know where our robots were at any given time and how they were being used. Because if you're making a silent robot, there are many use cases that might not be very friendly. And we did not want that we did not want our robots to be used that way. I was a conflict reporter. The last thing I wanted was to be a part of any proliferation of further conflict on the globe. We got into this to, again, save the seas and to have a positive impact in our waterways.
So starting up talking about the Save the Seas thing. So Aquaai is a startup that is making like a real impact on the world. How does it feel to be making the technology that is saving the planet? Do you think there is more scope in making robots that can save the earth from severe climate changes, or basically what is like the litmus test for a startup like this?
Wow. I think, that's always changing, especially when you're a startup. It starts out with, yeah, right, prove that you can make a robot look and swim like a fish. And we did that. And then it was like, yeah, right, who's going to pay for it? And we did that. So when we ended up in aquaculture, sustainable aquaculture, I should say, not because we thought, oh, let's go make fish to monitor fish, although it's a good story and I could sell it as a journalist. But that's where the first check came from. And always as a startup, we got into this because we wanted to save life. So yes, are we helping with food security? Absolutely, especially as the population booms and you have the need to have protein with a lower carbon footprint. So in that sense, yes, and we are only working with those who are sustainably minded as well. But beyond that, the litmus test, I think, for us is are we succeeded with the robot factor. And having I was in Haiti when the earthquake, right after the earthquake, and I can imagine how if we had more disaster robots roaming around, because we were spending a lot of time trying to find people, I really want to use my robots also for disaster response. The ability to maneuver around debris that we have, whether it's finding and whether it's looking at the toxicity of the water itself, or gathering that information for reinsurers, or even saving life if there's somebody and we're able to, if you look at what's happening, especially in the Mediterranean, when people are taking the boat over trying to improve their lives in different locations, if we're able to send a fleet of our drones out and to find people who need help, that for me is a success. Of course, there's climate. Monitoring the climate. We're going to start working with the European Space Agency, monitoring the temperature shifts in the ocean. I think there's so many ways that we'll be able to, and the ocean is a big place, and rivers, it's not about our product or their product. It's really, there's room for everyone, to work together and get that information, and hopefully up, blockchain, so everyone can access what's in their waterways and not be reliant on just what they're told. So for me, it's about putting that power into the hands of the people and understanding what's in their waterways.
So definitely a lot of scope there, I guess.
There's a lot there. And, you have to put your blinders on and you have to really focus and grow. But, we're always doing pilots or planning pilots, doing less this year because of COVID. But even that, they're doing more and more monitoring of waterways and looking for, obviously, disease, especially you don't want it to hit the Gulf Stream, whether it's influenza from fish or other diseases. So if we can mitigate and be that risk mitigating post-disaster technology, that for me, I've done my job. Already we have a lot of successes. Clearly the seal of excellence from the European Commission. It was a huge plus for us and validation for us. So we're on the right track. We just, I do think that it would be really great if more people got involved in climate technologies and these types, because they are becoming more affordable thanks to the biomimetic aspect or being bio-inspired. I don't think, and I hope Dr. Adams agrees with me, you don't need to have hundreds and hundreds of thousands of dollars anymore. We're not mapping the ocean. We're kind of keeping to the surface to about 100 meters down. where we believe the greater need is. But yeah, it would be really wonderful if there were more supporters out there in enabling these technologies to be developed, because the planet needs them.
I wanted to pull on two threads from that conversation. So one, you asked her what the litmus test was. And what I heard her say is we put our blinders on and we were really kind of focused on where we could use this application. And one of the things that I see happen over and over and over again with robotic startup companies is that the roboticist is like, I have this really cool idea for a robot, but there's no real application for it. There's no viable market for it. And that's really important if you're thinking about how do I do a startup and what's the litmus test? You know, where do you actually have a system that you can apply and actually have an impact? And then the other thing I wanted to pull on here is we're hearing Liane say a couple of times, you know, in the waterways, like in the rivers. And that's really key because a lot of the underwater marine robotics work is really done in the ocean. And there's so many things that we can do in the rivers that are so important. You know, investigating power stations, investigating our infrastructure, our bridges, looking at, you know, I live in Oregon and OSU is an agricultural school. So how do you monitor what's going on with the rivers with regard to the watersheds and irrigation and even water supply in Southern California, right? There's a lot of places around the world where the potable water supply is diminishing. So I think there's so many things that, you know, their system enables that a lot of other systems really can't address.
Yeah, I mean, and thanks for bringing that up. Actually, we did get an LOI in the earlier days when we were up in the Bay Area from the California Department of Waterways for the San Joaquin River to see what are the water characteristics there. There are so many use cases. That's not the issue. It's about making everyone able to use, which is, I think, the biggest barrier was affordability, which is where we really focused. And yeah, we've achieved success on that. And so I think we're on the right track.
I'm hearing this whole affordability part really clear. I mean, for both, I'm guessing Bioinspired Robotics is more expensive than like the normal robotics. Is that the case or something? But
I don't think it's more expensive. I think it depends on, again, what you're looking for, right? I mean, if I look at some of the robots for that deployment I was talking about, the field exercise we're going to do next month, you know, we average about $5,000 per robot. So multiply that by 150 or 250, right? That's quickly $1.5 million. Yeah. And that's just for robots, not all the extra stuff you need, right? Not the extra parts, nothing else. So, you know, you can use inexpensive robots, but affordability is really key. And it's not just for applications with, you know, agriculture, but in general, first responders don't have large budgets to go out and spend hundreds of thousands of dollars on robots. After the Gulf War, the military was selling packbots, iRobot packbots, to first responders. They were refurbished. They were still $75,000 to $200,000, right? And the reason that these first responders were able to get the robots was that they were able to apply to a grant program that basically paid for the robot. But, you know, most first responders don't have the financial means to go out and spend a lot of money on robots. If you think about, at least in the United States, 80% of fire departments, for example, are volunteer fire departments. So every penny they have, they raise through fundraisers, right? So can they go buy a $15,000 robot? Most likely not, right? So the affordability is really key, but also usability, right? Another key thing is being able to take that robot out of the package and immediately get it into service. You can't take, you know, in a first response scenario, you definitely can't take more than 5 minutes to get that robot out there. But even if your system, if you're trying to put the robot in with the fish, right, to monitor the fish farm, you know, that person doing that is not going to take an hour or 2 hours to do that. They're going to get annoyed. It's like saying that using your smartphone the first time is 2 hours to get your phone set up. No, right? You're going to go buy another phone, or you're going to go use something else. So
I think that's where a lot of people make a mistake, in that they develop these amazing systems, but they're so complicated. Who can use it? I mean, we were deploying, as I told you, our robot, you know, 2 weeks ago in gale storms. We literally got it down to 5 minutes deployment.
that's amazing. That's great.
5
Congratulations.
Thank you. You know, when there was an argument, I thought it was more like 6. They said, no, it was 5. Okay. But we got it down to literally, you know, you get on those cages and you're like, okay, you're carrying it. You know, you put it in the water. We use the communication device that we use as a top box, because the farm wants us to tap into their network, so we have uninterrupted feed. So that's why we use a top box for that. And so it's literally like, bam, throw it in the water, done. And then, you know, get out of there. So that was also, you know, you're absolutely right, Dr. Adams. It's so important to be, you know, the ease of use. I think my partner, you know, Simeon Piotrkowski, who's the inventor of our technology, the mind behind the machine, you know, he grew up in South Africa and on a farm. So he knew farmers are not going to want to spend, you know, hours or read a manual. If they can't figure it out quickly, it's not going to be used. And this is what you have a problem with a lot of devices, is they just sit there on the office floor, or they're not used because they're too complicated.
I think
in our case, when we're trying to deploy, you know, 100 robots, right, we've got 30 minutes to deploy them. You know, it takes us literally at least 2 days, if not 3 days ahead of our deployments, of just figuring out our logistics and exactly how we're going to do it and what we're going to do for that particular space that we're working in, right, for that field exercise. You don't have 2 or 3 days during a disaster response. You don't even know what's going to happen, right?
Exactly.
And so, you know, there's a lot of benefits to things like multi-rotor aircraft, right? They're very easy to deploy. Everybody can fly them. They're very stable. They are also a logistical nightmare. And then, you know, there's just also, like I mentioned, that we have about 4 different robots now. Well, that means 4 different types of batteries that all have to get charged. And for each robot, there's 3 to 5 batteries, right? So do the math. We're talking about, you know, over 500 batteries that have to be managed and charged, and you've got to keep track, because the last thing you want to do is put a discharged battery into a vehicle, have that vehicle attempt to take off, and then it crashes and is destroyed, right? So yeah, there's so many other things that have to go into that overall ecosystem that I was talking about.
While we are on that thread, I just wanted to ask small questions. That how can we ensure practicality in research while also maintaining novelty?
Excuse me, hang on. That's a really difficult question, and I'm laughing because the class I'm teaching next term is intended to address part of that question, at least for communication systems. You know, there are a lot of academics that really work within their nice little lab spaces and don't really go out into the field. I think the best way to get that experience is to actually go out in the field and attempt to do things. I also think it is important that those of us who do go out in the field, that we influence the academic programs and the other faculty, as well as the students, to make sure that people are being exposed to these concerns. However, it's not just in academia. I am on a board for a military organization in the US, and one of the things we've been asked to look at are all these other things that impact how are we going to have robots that actually function in an environment, even in a city, right? One person we were recently talking to said he was sitting there basically remote controlling the robot, and the soldier next to him said, "Oh, you need to stop there and come back." And he looked at him and said, "Why?" And he's like, "Because you're gonna be at a communications range." And then when he was attempting to turn the robot around, the soldier said to him, "Well, be careful, you're gonna end up in that ditch." And he looked at him and said, "Why?" And he's like, "Well, because the robot doesn't have sensors to sense that ditch," right? These sound like simple things and simple things that have to be fixed, but if you aren't taking your technology out into the environments where it needs to be deployed, then you don't know these things, right? If you think about a robot being in a hospital, well, you know, think about the scenario we're in right now with the pandemic, right? That robot has to be decontaminated on a regular basis. Most robots we build, you can't put Clorox on, right? They aren't hardened for that, to sanitize them. So, you know, there's all these things that have to be addressed.
So switching over to something for our fresh graduates in robotics. So what is the most important virtue or practice you wish your employee or student to have? Like, what are the factors that you have rejected a student or candidate based on that?
I'll jump in there.
Sure.
Go right ahead.
I have to say it's really hard to find people. And mostly because you have a lot of talent coming out of university settings where they've researched a lot in the lab, but have almost zero practical experience. And not only just with the robot, like how do you really use a robot as opposed to being on a simulator, but also how do you work in the environment where the robot is? It's not just the robot, it's the environment that the robot is in as well as the robot. So it's really hard, I have to tell you, and we, you know, we always, kind of one of the things that we do is want to teach robotics as well to the different locations that we go. We're always open doors for young people, especially those coming out of colleges that are not, you know, the top tier. We have an anti-MIT policy.
Sorry if anybody from MIT is on there.
No, we really are looking for people who have practical experience. And even for us, we live test everything. I mean, yes, we've lost robots, you know, it's gonna happen, but we live test everything. It's throw it in the water right now. Our lab is on the water, throw it in the water, test it. And you learn so much about your technology that way. And even now, you know, up there, this, you know, everything that we checked again and again and again was perfect. But some of the things that went wrong never even occurred to us.
Yes.
So it's really, I can't even stress, you know, more how vital it is that students or people who want to do robots are building robots. Our first question is, yeah, you want to be in robotics, great. Have you built a robot? Have you taken apart anything in your house and reverse engineered it and built something other from it? And that, I think, is and I'll shut up. I think that's the most.
I agree 100%. In fact, to get into our graduate program in robotics, you pretty much can't get in unless you've actually got real robot experience, whether it's formal research experience with a robot, you know, work in the real world with a robot. You know, if you've done FIRST Robotics, and don't get me wrong, I love FIRST Robotics competition, but that doesn't count, right? You actually have to have hands-on some robotics experience before we will even consider you for a position in our program. It's really key. So one of the unique things about our program is that we do require students to work on real robots in order to graduate. You cannot graduate from our program without having built or put code on a off-the-shelf robot and made it do something in the real world, right? So that's one of the requirements for us. So I would say I 100% agree. The other thing I would say, you know, I did not come from a usual place. I grew up in a farm. I should have spent my entire life running a maple syrup business in upstate New York. And I went to a small school in which I got a computer science business degree and an accounting degree and ended up doing this. You know, and you could argue that when I went to graduate school, I had, you know, grit and pragmatics, and I had the desire to continue to learn, but I knew nothing about robots. And I went to graduate school in a computer science program. So Penn didn't have a robotics PhD program then, or a master's program. But, you know, I think the other thing that I look for that's really important is the knowledge that you're gonna have to work hard, that you are going to continually learn. You know, it's lifelong learning. You know, if you are someone who thinks, okay, I've got my undergraduate degree, or I'm going to get my master's degree, and then I'm not going to learn anything else, no, that's not going to work. You know, I mean, you know, you just continually have to learn, and you continually have to evolve. Even at this point in my career, I still have to learn new things. I still have to evolve. So I think those are characteristics that are really important. And, you know, at least I have a reputation, and I've had a reputation at every school I've been at, in that I have very high expectations. And I can thank Regina Baichi, if you know who she is, for that, because she had very high expectations of the few females that existed in the GRASP lab at the time that I was there. I was, you know, I used to think she hated me because she was so like, you know, results, results, results. And it turns out that wasn't the case. It's just that she had very high expectations. And so, you know, students coming into my group, they have to have a lot of initiative. They have to have the ability to think broadly. And I think that's true in general for a lot of the faculty at Oregon State. I can't speak for other schools. And I sort of do have an anti-MIT policy just because, you know, I came from a small school and I wouldn't be talking to you today if people hadn't helped me along the way, so.
On that note, like, do you guys want to share anything about any opportunities you have at your school or Aquaai as well for our members?
So, you know, like I said, we are always open to taking interns. We've had interns in the past. In fact, tomorrow I'm meeting with somebody from NTNU here who also went to Delft, who wants to do their master thesis with us. We're incredibly open. I do believe that it's the next generation who's really gonna ride the robotic wave in much more than, say, like certainly my generation. So we're always open to those individuals. I do think also that, you know, the more women that we can get in, you know, this is women in robotics here, so the more women that we can support on that path of always learning. I mean, look at me, I was, you know, a journalist my entire life until 6 years ago when I founded Aquaai, and I never even knew what an ojoid was until this, and and all of that goes with it, and so it's, you can keep, you know, learning and evolving, and I do think a lot of it is supporting each other and being open, and, you know, try to answer every email back. I think that's another very important thing that people today don't bother to do. It could be the simplest question, but it can mean the world to that person who's trying to learn. And I think that finally, we need to ask ourselves not whether or not humanity is actually ready for robots, and what does that mean? Because I think that as we develop more and more of the robots, it's humanity that's lagging behind, and the acceptance of what does that mean when you have autonomous systems that are operable, or with, you know, using artificial intelligence, and you don't necessarily need the human as much. And how can humans take advantage of that, in the sense that what does that free time give them in order to develop our own society in a more positive way, as opposed to being more controlling or fearful because they can't control a robot. So there's so much there about understanding not just the robotic interaction with humans, but humans' interaction with robots.
Yep, I agree with that assessment. I think at Oregon State, so we have a National Science Foundation research experience for undergraduates, specifically in real world robotics, in which we focus on summer opportunities for undergraduate students. So I don't know if there's any undergraduates on here, but if you know undergraduates, then I would encourage them to apply. One of the things we do try to focus on are students who are not at universities where they would have the opportunity to really work in robotics. Our intent is to bring in students to ensure that they get that real experience with robots so that their application to graduate school will actually get them into a top program in the United States. So that's one of our key programs that we have. And the deadline for those applications, we were just talking about it in the meeting that I skipped out of. I think the deadline is coming up in about 3 weeks for that program. And then, of course, we have our robotics PhD and master's programs. We also, it's not widely known at this point, but we also just approved the first artificial intelligence PhD program in the country. And that program will be taking applicants this year. And so that will have a PhD and a master's program. And that also is a cross-disciplinary program, just like our robotics program. The application deadlines for those are in December. In my particular group, I am not sure if I will be taking on any new students next year. I graduated 3 PhD students this last year, and I had another student who's leaving this term, but I also brought in 6 new students in September. So my group, I have right now, between graduate students and undergraduates, I have about 20 advisees. So that's pretty big. It's almost like running your own company. And that's often what I say when people ask me, aren't you an academic? Don't you have summers off? I say, no, I basically run a small business within the confines of a university. So I do want to address one of the questions that was up there about, do you need a PhD to be a roboticist? So when we talk about what is needed to be a roboticist, you know, one of the things that we do in our program is we try to accept students who don't have that traditional engineering background, but perhaps got into robotics in a different way. And now they want some formal training. So that's one of the key aspects that we look at in our applicants. Another thing that we often talk about is that robotics is kind of like medicine. So as an undergraduate, you should be focusing in a standard discipline, if it's economics, mathematics, physics, even journalism potentially, you know. And then you go to graduate school to get that broader experience, but also that specialization, because robotics is such a huge field. Same thing with artificial intelligence, right? A lot of people think artificial intelligence is just machine learning. Nope. We apply machine learning in my group. We do lots of other types of artificial intelligence, and that's our bread and butter in my group. But, you know, the graduate programs are really intended to give you that specialization and that holistic experience, to give you that skill set that should make you more employable at various organizations. Now, having said that, do you need a PhD? No. We have a very large number of students who get their master's degrees and are going out and getting very good jobs. You know, jobs in places that are just phenomenal companies, both startups and not startups, doing robotics research. Can undergraduates go out and do that? Somewhat. You know, if you have a bachelor's degree, I think it's a little bit harder to do the kinds of things most people want to do in robotics. That kind of sweet spot entry point is probably like a master's degree. And I say that based on the applicants we receive and how many of those people have been out working in industry with a bachelor's degree in an area applicable to robotics, and they've been working at robotics companies, and they're just not satisfied with what they see as their career trajectory. And they have come to realize that having at least a master's degree will put them on a trajectory to allow them to do the things they're really interested to do in robotics and kind of move forward. I always talk about a PhD kind of being, degrees being like building a house. Your undergraduate degree is building the foundation of the house and kind of building the basic things of the house. So it has rooms, it has walls, it has a roof. And then your master's degree is kind of filling in the niceties, putting in those nice kitchen countertops and those nice kitchen appliances that you like, right? You're getting some breadth, but you're getting some specialization. And, so you kind of stay broad, but you're getting more information. But the PhD actually narrows you in. A proper PhD is going to make you very focused on a very specific aspect of robotics. And if your primary desire is to go into industry, you may not want or need a PhD to do that job. And so I think it's really important to understand that.
So at Aquaai, we don't care if you have a degree at all, to be honest with you. For us, it's really about whether or not you build robots and can build robots, and what where a lot of the people that we hire have done amazing things on their own. They're autodidactic, and they didn't quite fit into the academic environment. So that's not a deal breaker for us at all. It's really about, like, can you work hard? Can you learn? Are you hungry? And can you build with your hands? Can you think? Can you problem solve? Really, it's about problem solving. It's about reverse engineering and thinking and coming to the solution. And I think the more you just do that, the better you become, So yeah, for us, that's just from our perspective. That's never going to prevent you from getting an interview at Aquaai, whether or not you have a degree.
Now I totally get your anti-MIT policy. So this is like probably the last question for the evening, and probably one of our most desired ones. So what advice would you like to give Women in Robotics members and our young enthusiasts out there? So how can someone from a background outside of robotics join the field of robotics? So a general advice for everyone of our members.
I can go first. So, a lot in life, I tend to be somebody who's highly organized and like to have a plan. I can tell you that my life and my career have not gone to plan. It has been about opportunities and doors that were presented to me, and me choosing doors to pass through, and then having the appropriate mentors at those different points in life. While I was finishing my undergraduate degree, I worked as an accountant. I had an opportunity for a computer science job, and I thought it sounded boring, so I took the accounting job. And the accounting job, and I did a lot of things in accounting, the 2 years that I worked for Allied Signal, that went from doing expense reports and accounts payable to managing capital projects to doing the corporate taxes, right? So, and I also wrote the program to put my capital project system, integrate it with the general accounting system, something that you're not supposed to do as an accountant, by the way. But that experience really led me to questioning what I wanted to do. And so finding the right people to talk to, the right people to support you. Even when I left Kodak and went to Rochester Institute of Technology, I made that decision for personal reasons. One, I wasn't happy at Kodak, but I also was in a relationship where I thought I was getting married, and he'd been at Kodak for a very long time and wasn't leaving. And when I went to try to get back into robotics and was visiting some of my colleagues like Vijay Kumar and some other people at Carnegie Mellon, they were like, "What are you doing? Why are you at RIT? You need to be at a better school. You should be doing research." So that network you create is so important to opening doors that you wouldn't have otherwise. I think that's one of the most important pieces of advice, in addition to everything that was just mentioned, problem solving, all of that.
I cannot stress more on that, but yeah, I totally get it.
I'll keep it brief. For other women, I think there's two factors that I've noticed from an outsider's perspective. One, There's a lot of women that I feel that they say that, you know, they're unsure and they don't know and they don't know enough. And there's kind of like this inferiority complex that you just have to overcome. And if you're hungry for robotics, go for robotics and get over yourself. One. Two, I think that women who are in robotics, who have really created names for themselves, could possibly be more open to those who maybe don't have the PhDs. I know when I first started, you know, nobody would talk to me. You know, what is this? You know, and I do feel like I'm really happy now that my endurance over the course of the 6 years of having Aquaai, you know, warrants the worthiness to be able to even sit here and have this conversation. But I don't think it should be a matter of 6 years of keeping your startup alive in robotics to get you there. And I think those women who really are and have made names should open those doors for those people who are just entering and be a bit more gracious in helping and passing the baton and helping other women get those first breaks or get those relationships, find those mentors. I would love a mentor even today.
Yeah, I agree with that. You know, when I came back into robotics, some people were like, oh my God, where did you come from? Where have you been for 5 years? And they were very supportive, but other people were very threatened. You know, I've been very fortunate in having some big name females, you know, be very supportive, but I've also had some big name females be not supportive at all. And it's challenging because there's definitely personalities out there, and finding those right mentors and getting people to work for you. And when I went to Vanderbilt, I was the only female in the department. And so I think another thing is that, you know, I grew up in a time period where there weren't that many females. And so I grew a really thick skin to be able to deal with the males on a daily basis and to deal with a field where there weren't a lot of females. And because of that, you know, when I went to Vanderbilt, I wasn't overcome with stress about being the only female, but I did go out and I found the male mentors within my department for different things. And then I went out and sought external mentors, some of them female, that were either in robotics or in other areas related as mentors. And then I became that mentor for the second female that was hired in our department, you know? And so it's really important to do those things because it's just really, it's not a fun world to be in from that perspective. And there's still times today where I am the only female in the room. And, you know, I notice things like the males get addressed as doctor and I get addressed by my first name. You know, and that's not to say that you have to have a PhD, but it is something that you see happen. You know, and I tend to be I'm a very New York person, so I tend to be outspoken and I'll speak up for myself. But, you know, I think that's a key thing, is making sure that you are also speaking up for yourself, right? And demonstrating, don't doubt yourself, right? You know, be strong in the way that you present what you present, because you're intelligent and you know what you're talking about, and be strong in your presentation. Don't come off saying, well, maybe, or I might feel this way, or I might do this, right? You don't want those kind of wishy-washy things.
Completely agree.
Completely, I totally can relate. So this has been great. I mean, we are almost out of time. So I mean, I cannot emphasize on how much this has helped me personally, and I'm sure our members found this very useful too. And like, we are looking forward to some like mentors like yourselves. And thank you so much for this opportunity for us to get to know you, and this great advice and so much insight into bio-inspired robotics. I mean, this is a really rare field, and we have very few knowledge, less knowledge compared to other parts of robotics. So this was really, really great. Thank you so much. Dharini, would you like to add anything?
Yeah, I love the conversation as well. Thank you so much for sharing your story and coming here. And yeah, there were a lot of highlights of there are a lot of I was trying to summarize some of the important points, but there are numerous of a lot of them. So I hope we can summarize them for our viewers. But yeah, thank you so much.
You're welcome.
Hope to stay in touch with you guys. Thank you.
Thank you. Thanks for
Thank
having me.
you. Take care.
Thank you.
Bye.